Alright, so hello and welcome to another Bevy video. So today, like this morning when I woke up, Bevy 0.14 had just come out. Of course, everything is going wrong today. I got home from work. I did read through most of this article before starting. I put a poll out asking if people wanted me to stream me going through this or not. And like at least half the people last time I checked had said yes. So uh, I'm going to stream it and then I'll edit down the VOD and upload the actual video so people can like tune in if they would like. So everything's gone wrong. So the other day we lost power because they were doing something to the power line and fucking literally knocked over our power post. And then my computer doesn't want to restart now. I just get like to the grep screen and it's just stuck. So I can't boot Windows for some reason because it's corrupted the boot driver. And then I've tried everything to get that working. And so now I'm streaming on someone else's computer, which is always fun. But the big issue with that is it means that I've had to like install OBS and everything as quick as I can, get it all going. And I'm literally like got the chat on my phone if anyone wants to chat. Otherwise, I can't do anything because I don't have a second monitor or anything set up. But that's the disadvantage of just doing this kind of stuff. I don't even know if my audio is working. Should be. Let's check on my phone. So I can't get to it to unmute it. Hopefully it's working. Yep. Okay. I heard myself. That's all we need. Okay. So Bevy 14. So what's that entail? Well, apparently 256 contributors. So 1 byte worth of contributors with 993 pull requests, which is just like mind-boggling. In this, they added virtual geometry, which is basically breaking like really complex meshes up into smaller chunks so that it can then be rendered more efficiently. Shader screen, sharp screen space reflections, depth of fields, per object motion blur, volumetric fog, filmatic color grading, anisotropic PBR, which is to do with allowing like light to change depending on the part of the image that it hits. So it allows for materials to render like smear blurs instead of just point light blurs when they reflect stuff. Auto exposure, PF point lights, animation blending, observers and hooks, which is the big feature that I'm excited about because like there's a whole bunch of things that I'm like, man, I wish these had existed when I tried to implement this kind of stuff. Better colors, computed state and substate, which is another thing I think I talked about in my state video about how you could go about like you have to come up with a whole bunch of states or like multiple states. They've added it like computed states and substates was what I was talking about. Like these are not part of Bevy, but now they are. So that's amazing. And rounded corners to UI because everyone loves good rounded corners on their UI. So first up is our virtual geometry. They talk about this being very similar to the Unreal's geometry in their default renderer. So what it does is it breaks up the geometry into smaller chunks so you can have really complex geometry like this. And then each of these is like sort of what they call a meshlet or something. I think it's over here like, yeah, so the meshlets. And then so basically run it out of a sequence of meshlets, which allows for like basically dynamic meshing, where as you get further away, it will render less and less meshlets, which allows for what's called level of detail to change based on distance, as well as like it cannot render all the meshlets on the far side, which means that you can have really complex geometry without it causing you to have to like render all this unseen geometry. They say to add it, you have to enable the features in Bevy and then also include the plugin into your game. And this is pre-computed. It apparently all has its own shaders and everything, but there's somewhere it says about you can use the builder or something, and you pre-compute this basically when you build the application, and then when you run it, it's much faster again because it's all pre-computed at compile time. So it'll take ages to compile, but once compiled, it will run much smoother and faster with really high geometry models. And they just talk about the different shader inputs. So this is the next is these sharp screen space reflections, which just is, to me, doesn't look very different. No, looks the same to me, but I think that's kind of the implication. Oh no, it's the block. I was looking at the reflection of the building. The block is the reflection. Actually, that's really cool. It's even funny because the block's upside down, which means the reflection all up. I was looking at it going like the buildings reflected the background look the same. No, it's the block is there or not there. So this uses like ray marching or something to generate images, like 2D reflections. It samples the shadow somehow. I don't remember. I was reading to this. This rendering stuff is like all well beyond my depth, but really cool because it's something like you just add these 3 components here to your camera, and then suddenly you have reflections in water. So that's cool. And I think they also said there's a whole bunch of things like you can change the like level of detail and stuff like that depending on how much of your like compute you want to go to just working out the reflections. It's from the people that make TinyGlade, which is like a really cool looking little indie game where I think it's like waveform collapse style, like you build the environment and based on what's next to things they connect together. I think that was TinyGlade. It looked really cool. Like I saw a Reddit post on TinyGlade and I was like, that is such a cool thing to be making with Bevy. It doesn't use all of Bevy. It's like they've taken like the ECS and pulled it all out, and like they're using Bevy how like Bevy was described, like you can do this, where instead of using it as the engine, they're pulling the parts that they want and then building their own engine out of the parts. So that's pretty cool, especially considering they're contributing back like this cool stuff. So next up, volumetric fog, which is amazing. So you get like these God rays. So because it computes the fog, this is definitely ray marched. Somewhere it said about ray marching. No, can't find it. But it basically just means that instead of treating your fog as like as you get further and further away from the camera, the fog gets thicker and thicker. It actually can compute things like the fact that the light is coming through here, so this gets lit up better than this because there's a tree blocking it, allowing for God rays. And it's all they've gone real heavy into artistic design, where like a lot of these parameters are configurable. So I'm assuming like fog density and stuff like that, all configurable, and these are fog stuff. Fog settings, that's the word I'm looking for. So it's pretty cool. Looks really nice. Like what's going to be great about this is like if I get my Minecraft clone, like I can just turn the fog on and it will add just a whole cool effect without me needing to like compute and calculate fog and like work out all the stuff myself. Like the default stuff that Bevy includes now is just phenomenal. So next up, per object motion blur. This is basically just a change so that the motion blur is applied like per object. I think it's a component you add, yeah. So motion blur bundle onto your camera, and then it does this. So basically what it's saying is if the camera is moving with the car doesn't motion blur, the trees motion blur, but when the car moves past, it will motion blur that. They explain it much better up here, but it's basically just that it's relative to the camera's position, or like relative to the camera's view, not necessarily to the position of the camera. As in, these trees aren't moving relative to the camera, but they're motion blurring, whereas the car is moving relative to the camera, but because the camera's following it, it doesn't motion blur. It's also tied to the frame rate, which means that really high frame rates don't get excessive blur or something. They aren't subject to over blurring. High refresh rate. Yeah, so it calculates it based on the camera's shutter angle, which is to do with the frame rate of the camera. Which, for some reason, Bevy's going in the direction of like treating the camera that the game's viewed for as like an actual real camera, because you can change the aperture and you can change the f-stop and stuff to get like really stylistic design and view, which, you know, is all part of developing something like this. But I just find it weird that it's becoming more and more like they're actually like simulating a real camera, especially considering like, you know, calculating shutter angle and stuff. So then we got Volumetric color grading, which, to be honest, not really sure. I think it's to do with making like your lighting and your white, and they like look like white. So you put like your white there, and you can tweak all these values until the white looks like your white, and then you know, make all the other colors warmer or cooler. You know, it's all controllable at highlights, tones, shadows, and you can tweak these all individually to give you like the stylistic design that you want, like really dial in on that, like looking like a movie kind of thing. So this is one of those things is like I don't think a lot of general people will use as much as like they're making Bevy for like if lighting is your thing, you'll love this. Or if you're in a professional setting where like you're actually hiring someone whose entire job is to make the pictures like make it look great, they will understand all this terminology. To me, this is a lot of like I kind of get what it's talking about, like there's exposure and temperature and like tint, hue, and gamma. So like these are all things like I kind of know what they do, but not enough to be like, oh, I know I'd like to tweak this image. I know exposure will make things brighter because it's exposure. Temperature changes like the blue redness of a light. Like a really high temperature light will be already white, with it like a tinge of blue, whereas a low temperature light will be quite orange, like this image here, where it's like basically it's orange. Hue is just, you know, through the color wheel shift, and then tint I'm assuming is just another thing again. But yeah, it's one of those I don't really know enough about lighting to explain this well. Auto exposure, this is something that's kind of cool. So Bevy let you change the exposure of the camera, which would like basically, you know, you can make dark rooms really dark where only the lightest things can be seen, that kind of thing. And now they've got an auto exposure that lets you like dynamically change how much is visible. So as you can see here, like when they look at something bright, you can't see it, and then the auto exposure comes down and you can actually see the image, but everything else goes black. Look away from it, and the auto exposure goes back up until you can see the difference in like shades of green again. So I think they do talk about like it's not really intended to just be used by default. It's off by default, but instead to be used in very specific places where you're trying to get like a desired effect like that, where when they walk into a dark room, they can't see anything because they were just somewhere bright, and then it slowly adjusts in. You could have like a survival game where you use this auto exposure so that they can't see when they go from bright to dark and something like that, or like, and then when a flashlight gets used, like it can blind people or like that kind of thing. Could have really cool effects that can be used, and you know, all built into Bevy, so no need to program it all yourself. What do we got next? Next is fast depth of field. So basically, depth of field is the idea that things in the background can be out of focus, things in the foreground can be out of focus, and only the things in the middle are in focus. And so now they've implemented that. They said the default's a Gaussian blur, which is fast, but you know, not the best looking. And then they've got Bok blur, which is where the blur like looks like the shape of the aperture of the camera, which means in this case they're using a hexagon. And so if there was like a point of light here, it would be a tiny hexagon because it blurs into a hexagon. And you can actually, not with Bevy, but in real photography, you can actually make that like do whatever shape you want. So you can have like lots of lights out of your depth of field through like a pinhole shape of like a tiny elephant or something, and then all the little pin pricks of light look like tiny elephants. It's actually a really cool photography technique, but basically Bevy's implemented it so that like you can have your depth of field look really cool. And okay, this is that the PBR and anastropy. So the idea is that this is what your normal specular highlights would look like, just points reflecting light. But what Bevy's done means that because this is sort of like brushed this way, like it's been polished that way, the light actually sort of scatters up because it scatters more up and down than it does left and right, which makes a sort of a narrow width and a tall height, which gives the appearance of a line through it. And yeah, so you can just do that now. So this is again really cool lighting. Like it's a lot of this update seems to be quite visual based, but some of this stuff I'm also just like super excited to try my Bevy through the ages and just like add the 0.14 update to it and see how much faster this is. I haven't seen anything talking about the performance improvements, but I'm just hoping that there's some stuff in there that's like, yeah, it's just so much faster. So what else we got? Percentage closest filtering. So this is, I think it's an anti-aliasing technique to just it makes shadows smoother, so you can see here all the dots, and then there you go this, and it's sort of like more blurred, and it's basically saying that they sample like there's something about a kernel somewhere. I saw it somewhere. They're sampling basically like a square of pixels around that pixel, and then taking the average of that to work out what it should be, which means that you sort of end up with smoother edges rather than sharp edges where the light suddenly stops. Instead, you sort of end up with a nice blend from light to dark. What's next? Subpixel. There's a subpixel morph anti-aliasing, which is again like it's. I wish I knew more about rendering, but like yeah, so it's just anti-aliasing. What type of is it? Something like subpixels. So it must anti-alias just like on a smaller resolution. Jagged edges, wide array of anti-aliasing techniques have been with SMAA, right? Subpixel. Okay, so it's just another form of anti-aliasing. I really don't know how it works. All right. Visual range. So this is one of those things that like I'm like, oof, this will be great for some games, and hopefully like like Minecraft clone, that kind of thing, where Bevy now has built-in features for level of detail. So I don't know how to use it because again I don't even have videos or pictures, but it basically just means that based on the range the object is away from the player, the further the object is, you can make it swap to a lower resolution mesh beyond a certain distance, so that you don't render really high resolution stuff that nobody can see the detail of, which for my voxel game would be kind of cool because you could like you could generate like a few different chunks. Say like you generate like the full depth, full detail chunk where every block is rendered, and then you do one where only the even blocks are rendered, and then you do one like where only every fourth block is rendered as filling the same space as the 4 blocks, and then pass that off. So it's like when it's so far away, it'll only render like a quarter of the blocks because it's not going to render the stuff that you won't be able to make out the detail of, and it should look really good and increase view distances without necessarily decreasing performance. Onto the fun stuff now. We've got hooks and observers. So Bevy had a pull style of events. So the idea being that the events are queued and you go, hey, I'm ready for my events, and you take them down. This is the fast method, but has some overhead. But it does mean that like you only process events like when they're ready, rather than like waiting for something to send your events. But hooks and observers are sort of the opposite of that. So they process events immediately because it's like a push style. So when the event happens, they push the event to be executed right away, rather than waiting till like the next frame for the system to come in and be like, okay, let me process these events. So slightly slower, but doesn't have the overhead of having to constantly check to see if everything's ready like to be processed. But the big advantage is, so they talk about it down here, is the life cycle hooks. But so hooks are specifically programmed like much more restricted in what you can do with a hook, but much faster and better executed because the hook is more restricted, so they can add optimizations. And an observer, like you can literally write like basically a query that whenever the query gets true, like the hook, the observer runs. Or whenever the event's just pushed, like if you just say like, oh, this person joined the server, it's like the event runs. So hooks tie into the component lifecycle in that you can now implement a component yourself, and you can say, hey, when this component is being created, like I want to add an on remove hook, which means that when this component is removed or the entity that this component is attached to is despawned, I want you to run this piece of code immediately. So their example here is that you have a target and a targetable. And so the target here can pick an entity that's targetable, and then it'll add itself to the list of targeted, like who's targeting this entity. And then when you despawn this targetable entity, which would be like the player's targetable, and every enemy has a target that they're going for. When you despawn this targetable, it will then go through all of its entities that it's targeting, or that are targeting it, and unassign them from targeting anything. Which means that, like, if a bullet hits the player, then suddenly all the bullets are no longer targeting the player, or all the enemies stop targeting the player. which is like a really cool way of doing this, because like it was something I was trying to implement where this would have been really useful, is to have that ability to like, I think it was like loading a scene or something, is to have that ability of like, when the scene is loaded, I want you to go find this thing, like say like when a chunk mesh is spawned, or like when an entity inside of a chunk of other entities spawned, I want you to go find the parent chunk, instead of me having to spawn you inside the parent chunk, or the world entity. It's like whenever I spawn a chunk in, I want you to automatically find and set its parent to the world. So that's something that's going to be really cool to do. And it's observers are just the same thing again, but like on a much more unrestricted way. Like you can just send a message, like so like world.observer, and then the trigger says that when you send it a message, it just prints the message, and then you can just in any system send and trigger the message. So that's pretty cool. And it happens immediately, which means you don't have that 1 frame delay, or the risk of a like system missing an event because it didn't run every frame and the events are cleared every other frame, so it missed events. What is next on the list? Something. I missed it. Where is it? So GLTF texture transform support. So this is just an expansion on GLTF to include it can now like apply transforms. So it's, I don't really use GLTF much, but it just means that like more of the GLTF format that you can export from Blender, and that is now brought into Bevy and actually respected. Like you can morph a texture before applying it, I guess. See, like this, so the bricks, and then you're saying like scale them down. So basically it automatically scales it down because it knows this now. Then we're going to do the UI nodes with you can now radius the corners on a border, so all left, right. So this is okay. So this is with a border, and then like the top left is radiused. Top bottom, yep. Top. So basically, just it allows you to specify a border radius, and then you can do all that cool stuff. You can now do animation blending with the animation graph. Again, I haven't really read this much because I didn't quite get this far, but it just seems that it's like you can like just expand on top of the animation. So you load this clip, and then animation graph.add clip, and it loads another clip. So I think these are sort of chained, and then they must blend together somehow. So the improved color API is that Bevy, I think, now represents everything as linear RGBA, and then implements a trait on top that implements the trait hue and alpha for the types that use that, allowing for a much better like easier time using the functions of a data type, because if it doesn't have so instead of having the color struct that they had, that then had a color and then sRGB, and then having your hue, saturation, lightness, instead of having those as as enum variants, now they're their own struct, and so you don't have to have a hue option on your sRGB, because sRGB doesn't understand or respect the concept of hue. That's a hue, saturation, lightness concept, and so you only implement hue when the color space actually allows for hue shifting or hue measurement. Otherwise, I think it don't know if it's here it mentioned or later on. It says you have to convert to a different color space, change it, and then convert back. And maybe it's something else. It had a hue option, and if you change the hue option, it converts to one color space, shifts the hue, converts back. And this, I think, just makes it slightly more clear. But so you can also have things like mix, and I'm assuming mix will take in anything with a color, because you can just convert the color to sRGB and then mix them and then convert them back. But at least made it so that the colors are more versatile and useful for people wanting to use their color space rather than a custom color space. Okay. Extruded shapes. So Bevy's 2D shapes can now be extruded out into 3 dimensions like this, and you can also like query things like their bounding box, their volume, their area. I guess this must be something that they added in the previous one, that you could measure 2D, and so you must be able to query its area and perimeter and stuff. But now you can sample its volume if it's 3D, and you can extrude 2D shapes into 3D, which is pretty cool. They've added more gizmos, so now there's like a corner chopped out gizmo and a rounded corner gizmo, grid gizmo, which will be really useful for things like my voxel based game. So, because then you can render the chunk boundaries as a grid rather than having to just sort of know where the boundaries are. There's now a coordinate axis gizmo, lighting gizmo, which is neat. So that I guess is like your point light and your directional lights now have like a gizmo, so you can render them and see them. And I'm assuming this is probably like a spotlight, maybe this is a spotlight. This might be a directional light. I don't know what the yellow one is. It's not seeming to light up anything. It must be a directional light, and it's because it's in front of these blocks. It's not lighting them up. Gizmo, line, style, and joints. So you can render lines and just tell it how it renders around a corner. So like this one is just, I guess this must be mirror, and then this one's rounded, that one's chamfered, and this one's something, I don't know. I guess this would probably be none, and this would be the bevel, which is actually a chamfer. But anyway. And then also there's a UI node gizmo, which just draws an outline around the UI node, which is kind of cool. Useful for debugging, not so useful for actual game situations, but it lets you implement like Minecraft's F3 menu and stuff like that. So, you know, there's use cases for it. Okay, and then context clearing gizmos. So basically they said that instead of clearing once per frame, I don't actually know what it clears on now. But it allows you to use custom schedulers instead as well. So it's now multiple storages for different context type parameters. You can set the type of gizmos issues to store to write to. You choose which store you add, get drawn or cleared. Any gizmo is the default storage context during the last. So I guess this means that like you can have gizmos that aren't necessarily re-rendered every frame. So like the way that gizmos work at the moment is they're immediate mode, which means that you have to say every frame render this gizmo or it doesn't render. And this I think is saying that you can now say like these are gizmos that need to be rendered every frame, and it's like, but the colliders, they don't need to be re-rendered every frame. They'll just stay on screen. Like you don't have to tell every frame every time a frame happens to render it again, which will be good for like my Minecraft clone. The big thing that it ran really slow when you turned on the collider visualization, and it's like part of because it was every frame it would be redrawing these gizmos and recalculating all the gizmos. Whereas this is like it'll draw them every frame, but it doesn't recalculate them because it's not immediate mode anymore. So you can say when clear all the gizmos and when not to clear the gizmos, but also have different sets of gizmos that can be cleared and not cleared. So yeah, that's cool. Query join. So this allows you to have two queries, and you can join A and B, and then you'll get a new query that only contains the items that are in both A and B. This allows you to basically do like two small queries, or like a big query, and then like a sub query, like with some other thing, and then you can have your big query, do something with it, and then be like, okay, and now I just want to filter out everything else, so it's just got the smaller query, but also all the stuff in the big query, and so you can do really cool like it's like mixing and matching of the query, like where it does both sort of thing. It also appears that you can extract the entity without necessarily querying for the entity here. Like you can have A, have B, and then you can query it and get the entity as well. But that's probably always been something you may have been able to do. I'm not sure. It's just interesting that the signature changes like that. So now we're on to another one of those exciting ones. This is computed state and substate. So basically a computed state is like a state where you can have multiple states that may be classed as in-game. So your in-game paused, whether you're paused or unpaused, you're still in-game, so that can trigger the in-game state. You may also have a whole bunch of other things. The example they give up here, which is better than the in-game state that I'm trying to give, is in menu. So you may have a main menu, a pause menu, but all of them will trigger the in-menu state. And then you can have logic that only runs when you're in a menu. You can only have logic when you're in-game, and all these things happen. And so that's like a computed state. And then there's substates. And so substates are like states that are only implemented into the game while you are currently like in another state. So like this setup, battle, and conclusion are only a valid state while you're in game. Otherwise they don't exist. So you can actually rely on the existence of this being a way of like determining certain logic of your game. So this macro means that game phase will only exist when in-game in-game computed state. So you don't have to check if every possible state that could flag you as in-game exists before you remove this, because you just like the computed one will determine that you're in-game, and then this will determine which phase of in-game, instead of putting the game phase inside the in-game struct. Like it's a way of like splitting everything apart so that Bevy manages which states enter and exit of things. And I'm pretty sure, like I mentioned this and was talking about how this works and like how this could be difficult in my states video. So you know, it's nice to see that I wasn't just like talking out my ass. It's like this is something that Bevy was looking into. And then to initialize it, you don't initialize the state and then the computer state and substate. Like you just initialize them, just like any other state. They have a non-exit next state. Oh. And here's another thing that I think I mentioned in it. No, this is something I mentioned. Maybe this is something I think I did in my Minecraft clone. Maybe is state scoped entities. This is like when you enter into a menu, all the menu items can be state scoped so that when you exit the menu, they'll get despawned. In this case, there are state scoping it in game, which means that when you leave in game, it despawns everything that was in game. And it just means that you don't have to write those tacky cleanup functions and systems that I have to write whenever I'm doing something like a menu where it's like, I'm like, hey, this is what the menu's called. And every time I spawn stuff in that's in the menu, I tag it with like a menu thing. And then when I leave menu, and then you have to remember for every menu to add. So this is like, hey, you can just say to it, like, when you exit in menu, you delete all the menu related things. And then you can then have each of your different menus all set the game state as in menu. The computed state as being in menu. So it's a really good like boilerplate cutting down thing of like making it much easier for say like I wanted like an API level plugin, like if Belly ever got updated, which I don't think it will, but if it got updated to 0.14, like it would give it the flexibility of being able to provide you like, hey, mark it with this, and we'll take care of clearing it when it's done. And Belly doesn't have to actually track anything; it can just set up all the correct things, which is pretty cool. State identity transitions. Because there's a niche feature on X energy schedule will be ignored, and the new identity transform by default. But you can users have sometimes asked us to trigger exit energy steps when moving from state to itself. Okay, well this has its uses refreshing in the core. It can be. In other cases, we found it might let the user hook into the type of transition if it is something you need. Okay, so basically we're saying like you can change whether a state will trigger a on enter when going from itself to itself. So that's cool. Like again, it's more like flexibility for people that want to. This is something that probably speed up my my Bevy. Maybe not though, because I think I specifically avoided any frustum culling in my tests, but GPU side frustum culling which is just basically the camera has the what the camera can see, and then you go a little bit further than that, and anything outside of what the camera can see you don't render. So that's frustum culling. The frustum of the camera is what the camera could possibly see, not necessarily what it does see, but what it could possibly see, and then you just cull that away. Anything that's outside it, there's no way the camera can see it, so it's gone. And then your GPU side frustum culling means that instead of your CPU having to go through everything and going, hey, can it just sends it all to the GPU, and the GPU then goes, hey, can I see any of this? What of this can I see? World command Q. Huh. Okay, so this is another one of those, like, I don't think I've ever actually done this, but you can send commands when you have mutable world access, and they're saying is what you had to do in the past is you had to create a commands queue and then generate the commands component and then run your commands like you would in a normal system. But now they're saying, like, if you just have access to the world, you can just say world.commands, the commands to spawn. Like it's now just basically like wrapped inside a convenient function. They've reduced multi-threaded executor overhead, so that's nice, but I don't think that changes much unless you've got a lot of threads running. Can take up to 30 microseconds if for that thread is cold. Minimizing these switches is important optimization for this executor. In this cycle, we load 2 changes that slow. Improvement is run the multi-thread executor at the end of each system's task. Okay, and combine event update systems. Okay. So they've also apparently decoupled background color and UI image. UI images can now be given a solid background color, right? That's nice. Background color. Yeah. So I think this is just something that if you're needing it, it'd be really, really good, but otherwise not noticeable. Combined win-int events. When handling input events, the existing ordering of the event received is often very significant, even when not the same type. Drag and drop operation. When exactly did the user release the mouse button relative to many tiny movements that they perform? Getting these details right goes a long way to responsive. Okay. Okay, so what they're saying is instead of they now expose the raw win-int event rather than, well, they probably also still split it up. So it used to be that you could track the mouse movement and then you could track drag and drop events. But they're saying, like, you needed to know exactly when the drop event happened so that you don't keep tracking mouse movements after it's been dropped. So now they're like, the win-int event will actually export the whole thing so that you know exactly what the last mouse movement was before the drop event happened. So that's fun. Okay. Recursive reflect registration. Okay. Process data, things like serialization, deserialization. Bevy has the type registry to keep track of which types exist. Users can register their custom types. Okay, yeah. So we can register custom types. So I suspect what this is saying is that if we say register type, that's fucking incredible. Like, yeah, how many times I've been registering types? So basically, what they're saying is in the old Bevy version, you used to have to register your type, and your types, data relies on blob, so you had to also register blob, and then blob obviously contains a vec of U8s, so you had to register vec of U8s as well. Now, when you add it, it will register all the dependent, all its dependent types, and then they will register all their dependent types, which results in you only having to register the one thing, and then all the required types will be registered. This is great because there's a few things that, like, just small things like the Bevy editor please had a couple of crashes that I know about, like when you tried to serialize something or save the serialized file, it would crash because some type was not registered. And it's like, well, now if you're trying to register, if you register the camera, then all of the camera's components are registered. Which probably still wouldn't help with those crashes because I'm pretty sure they were just individual components. But it's to say, like, it means that no sub part of a component will be missing from the thing. ROT2 type, ROT2 type for 2D rotations. Okay. So if we wanted to work with rotations in 2Ds, get frustums with having to choose between a raw. Okay. Added a convenient ROT2 type for you. Feel free to replace the. Huh. Okay, so I guess it's just to do with like rotations. Instead of just using a F32, you can now use ROT2, which I guess represents it as a quaternion. Okay. Okay, alignment API for transforms. Oh no. Oh no. Oh no. How do I go back? Okay. There's a new transform align function, which is a more general form of lookat, which allows you to specify any local axes you want to use for the main and secondary axes. Okay. This allows you to do things like point the front of a spaceship at a planet while while keeping the right wing pointed in the direction of another ship, or point the top of the ship the direction of a tracking beam pulling it in, while the front rotates to match the bigger ship's direction. Okay, so it allows you to specify more details about the axes when you put it. Okay. Random samples of shapes and directions. So it's something about like Bevy must have randomness now. Whenever interest in driving behavior of an NPC, creating effects, or just trying to create variety to help support this, a few random sampling features have been added to the Bevy math. Okay. Get it behind the rand feature. Okay, there we go. Yeah. Because I was kind of like, I'm sure I never updated random numbers. I've used rand, but it's Bevy has these implemented for if you're using rand. They are primarily geometric in nature, and they couple of flavors. First one's a simple random point for the boundaries of it. Arithmetic primitive. So basically, you can sample a random number and it'll be within a triangle. Sample a random number will be with a square, circle, rectangle. Whatever this thing's called. I want to say pill, but pill's not right. It's got a fancy name. Okay. Encode it's performed a couple of different ways using this. That's mind-bogglingly complex. Tools for profiling GPU performance. Okay, cool. Timestamp queries, pipeline statistics. So basically, if you're trying to benchmark stuff, Bevis now has features, so that's cool. New geometric primitives, rhombus, arc 2D, which is like a segment of a circle, triangle 3D, tetrahedron. Okay. Annulus. I don't remember what an annulus is. Circle segment. And circular section. Okay. Improve point and rename it to vector space. Okay. I'm just gonna start speeding up because I think we're like halfway through, and this video is will already be like an hour long, so that's always fun. So 2D mesh wireframes. So then basically you can now render wireframes for 2D meshes, custom reflect field attributes. Wait, one of the features of Bevy's reflect system is the ability to attach attribute type data to a type. This is most often used to allow trait methods to be called dynamic. However, some users saw it as an opportunity to do other awesome things. The amazing Bevy Inspector GUI used type data to great effect in order to allow users to configure their inspector UI per field. Right. Take inspectors from this. Taking inspiration from this. Bevy 14 added proper support for custom attributes when deriving reflect. So users and third-party crates should no longer need to create custom type data specifically for this purpose. These attributes can be attached to structs, enums, fields, or using the reflect at syntax where the ... can be an expression that resolves to a type implementing reflect. Huh. We could have also used trust. Huh. Okay, so I don't know how this works, but I guess it's saying like you can reflect range inspector 0 to 1, and that somehow restricts this float to being within a 0 to 1. I know what it's trying to say, but I just don't understand how it's trying to implement it. It's basically saying that like the Bevy inspector EGUI, which is what the Bevy editor please uses, implemented what do they call it? Attributes that it could use to like influence how the editor worked. But now they're saying that like they've implemented that as a first party thing that you can now tap into field.get attribute. Okay, so it's like an attribute that's actually encoded, so you can reflect an additional piece of data attached to this, and then you can request that additional piece of data. So like additional, like, so you could reflect a name, and then you could request the name. And okay, so that means it must still be stored like in data, so it's like not related to the type, but important to reflect on how it's going to use that type. Hey, test struct. Oh, the Bevy editor when it comes out is going to be amazing. I mean, even just doing that so the Bevy editor please has an easier time implementing and maintaining its editor is going to be great. What is next? Query iteration sorting. Bevy does not make guarantees about the order of items, so if we wish to work with query items in a certain order, we need to sort them. We might want to display the score of the player in order, or ensure a consistent iterator over the set for the sake of network stability. In 13, a sort could look like this. Okay, so basically they're saying you had to collect all of the entities from the query, and then you could use them. This is especially unwieldy and repetitive with sorting within multiple systems. Even if we already want the same sort, different query types make it unreasonably difficult to abstract away as a user. To solve this, we implemented a new sort method for the query editor type, turning the executor into sort by attack. Okay. I mean, it definitely is much smaller. That's nice. To sort out queries with an attack component, we specify it is a general parameter to sort. To sort by more than one component, we do this for the component order in the type. We can do so independent of component order in the original type. Okay, see, in defense attack. Okay, the generic parameters can be thought of as being lenses or subsets of the original query on which the underlying sort is actually performed. The result is then internally used to return a new sort query iterator over the original queried items. With the default sort, the lens has to be fully ordered, like with sort slice sort. If this is not enough, we also have a counterpart to. Okay, so it's saying that like they also have the 6 different types of sort that you can do. Okay. The generic lens argument works the same way as the transmute lens. We do not use filters. They are inherited from the original query. The transform lens has some niche additional features which allow for this. For enemy in enemies iter.sort unstable entity. Because we added it to any lens. Okay, so this is. Does that mean lenses are not from this version? Because I didn't see them mention lenses earlier. But anyway, that's what I'm saying. Like it appears that you can just add entities if you would like to combine things. So say because we can add entities to any lens, we can sort it without including it in our original query. So you don't have to include entity, but you can use entity. That's nice. These sorts of methods work with iter, mute. The rest of these iterated methods of query do not currently support sorting. The sorts returned query sorted iterator, the self and iterator, and okay, so you can sort an iterator and then do other things like filter it, stuff like that. Keep in mind that these lenses, that the lenses does add some. Do keep in mind that lenses add extra overhead. Obviously, they do because you're doing more with the iterator. Like you've got to at the very least like iterate through it to sort everything. There's more overhead. You can't just use them willy nilly. You gotta make sure you only system builder. Bevy uses love systems. Yes, we do. So we made a builder for these systems so that you can build systems from within systems at runtime using dynamically defined components and resource types. Okay, this is going to make scripting amazing. And that's all I'm going to say, because that looks complicated. I'm just going to move on. It's got so much to go. Throttle render assets. Using a lot of assets, unloading lots of bytes on the GPU in a short time might cause stutters due to render world waiting for updates to finish. Okay. Often it is more delightful experiences viewer preference. A few frames without delay before seeing an asset appear is often not perceivable. Okay. So what they're saying is you can set you can sort of set how much memory can be sent to and from the GPU in any one frame to stop the GPU from having to wait for all the memory to finish transmitting before it can render a frame. And they're basically saying that this may result in it being a couple of frames before something renders because it needed to wait for all the data to come across. But this is favorable than the game stuttering because memory is getting sent across. And most people won't even notice that something popped in a couple of frames late. Standard material UV channel selection. Previously, standard materials allowed default use of the UV0 for each texture except light map, which isn't flexible enough for a lot of GLTF files. In 14, a new UV channel enum has added, allowing you to select the channel to use from each channel to use for each texture in a standard material. Having a before and after showing the support for attribute UV1 across textures. I don't get it, but okay. I'm sure that'll be useful. Removed limit on render layers. There was a limit on render layers. Okay, so apparently you can now toggle the visibility of lots more things. Okay, on unimplemented diagnostics. Bevy takes full advantage of the powerful type system Rust provides, but with that power can often come confusion with every minor mistake we are made. When even minor mistakes are made, running this above it would produce a compiler error that looks like this. Right. The trait resource is not implemented for my resource. Yeah, okay. I do this enough that I know. Yeah. The compiler suggests we use a different type that implements resource, or that we implement the trait my resource, or the trait on my resource. The former doesn't help us at all. The latter fails to mention the available derive macro. With the release of the new Rust version of 1.78, Bevy can now provide more direct messages for certain types of errors during compile time using diagnostic attributes. My resource is not a resource. Example, app new, insert resource, my resource, invalid resource, required by a bound introduced by this call. Help, the trait resource is not implemented for my resources. Note, consider annotating my resource with the trait derive resource. The following other types implement trait resource. Accessibility. That seems like it's going to be annoying because like lots of things implement resource. Okay. Now the error message has more appropriate endpoint and a new note section pointing to the derive macro for resources. Okay, that's really cool because that's something that's been shitting me off sometimes with Bevy, is that like if I haven't used it in ages and then I start using it, it's like it's very easy to mess something up and just have it like spit out an error that I'm like, what is wrong? Like, what am I doing wrong? So the fact that like now it's entirely possible to have an error message that like we actually can go like, hey, I know what this error message is. That's awesome. Motion vectors and TAA for animation meshes. Back in we added temporal, which uses motion vectors to determine how fast an object is moving. However, we only added meshes for static meshes, meaning it did not work for animating meshes using scale animation. Okay. Yes, motion vectors throughout have the same limitations. Fortunately, we implemented motion vectors for skeleton meshes. Okay. So I don't know what a motion vector is in terms of like, I think it's like, if I remember what they talk about in 0.11, it's basically like each pixel is given like the speed that it's moving, like that, so that when you get to the end, you can each pixel is set to the speed of the object that caused that pixel to be rendered, which means that when you run your temporal analysis, anti-aliasing, it sort of knows which way that pixel is going to be, where that pixel is going to be in the next frame, like it knows its direction of movement. And they're saying when they implemented per object motion blur, they needed this vector everywhere, not just on static objects. And so they've implemented this motion vector onto all skinned meshes, which means that now our temporal anti-aliasing will work on things like bone rigged animations. So it's cool. Improve matrix names. Provide a set of matrices to perform space transformation to given game. Okay. So this is like a shader thing, like if you want to like world space and camera space, that kind of thing. Typed GLTF labels. Okay. If you're using GLTF files and scenes, you or looking at the examples that might have seen labels that end at the assets path. Yes, like this is the scene and this is animation 1. Oh no. What? Notice the scene 1 syntax at the end. The GLTF format is able to contain many things in a single file, including several scenes, animations, lights, and more. These labels are a way of telling Bevy which part of the file you were loading. However, this is prone to error, and it looks like an error snuck in. The hen animation got the label animation 1 instead of... Am I stupid? Animation 1? I'm assuming it's spelled differently. A-N-I... A-M, okay, instead of M. I'm dyslexic, so they look exactly the fucking same. Like, I was gonna go like, it's the same word twice. But it's not. Okay. No more. The above can now be rewritten like so. From asset load asset. Okay, so we can say load GLTF load scene from asset. So that is nice. We can pass it in a... Okay, so basically, like you can now specify what part of the GLTF to load, and then pass in the file. So that's this. Does this only work for GLTF? I guess it's the GLTF asset label. I'm hoping this is like flexible enough that we could make our own asset labels as well. Like if we make a custom asset type. Winit 30. I don't think that's particularly important. They've updated to Winit 30. Adds idle loop has not started yet running. Scene mesh, mesh and material extras, GLTF models. File format allows passing additional user-defined metadata to the and in addition to the at primitive node level. Bevy now has specific. Okay, so again, they've just expanded the GLTF, like what parts of GLTF Bevy can now extract. Resource entity mapping in scene. Bevy dynamic screen is a collection of resources and entities that can be serialized to create a collection like prefab or save data. When dynamic scene is deserialized and written into a world, such as when the save game is loaded, the dynamic entity inside the scene must be mapped to the newly spawned counterpart. Previously, the mapping was only available to entities identified stored on components. Okay, embedded resources can reflect map entity resources and implement the entity map trait to get access to the entity mapper. Melting my brain. So basically, the way Bevy had it is if you saved a scene, any entity references in that scene would be changed so that they point to the appropriate entity in the save scene, and therefore when you load them, an entity pointing to a specific other entity is not going to have the same entity anymore, so it would change which entity they're pointing at so that that's correct again. And it only applied to components, but now it can be applied to resources. Compass quadrant, compass octant. There are many. Here's where it's important to know the compass facing for a given direction. This is articulate true in 2D games that use 4 or 8 direction sprites, or what to map analog input to a direction, discrete movement direction. Okay. I'm not really sure what this is saying. I think this is saying like you can convert a vector into being like north, south, east, or west, or like 8 directions, so that you can more easily make like a Pokemon style thing where when they're moving up, they have a different sprite than when they're moving down. Not entirely sure. This this video is like this live stream is getting too long for my brain. Uh, this is going to be a hell of a video to try and edit down. What do we got next? Support async seek when loading assets. Assets can be huge and don't always need all the data contained in a single file. Bevy allows you to add your own asset loader. Starting in Bevy, you can now seek to an offset of your choice, reading pathways through the file. Perhaps you have a celestial file format which encodes the universe, but you only look at little asteroids which always appear at some offset. Okay, so you can like read it. So this is done inside Asset. So it lets you not have to process every single byte of a file in order to render to like load assets. You can like skip the first bit, which is probably why a bunch of the GLTF stuff now works, is that they're using this to be able to like skip around the file a little bit more easily, which is nice. Okay, load status failed now has error information. Okay, that's nice. So basically, when it fails, a full asset loader error is included with 14 different variant types telling exactly what went wrong. Great for troubleshooting and opens the door to proper error handling in more complex applications. So that's nice. So basically, if your asset fails to load, you can actually like provide an error to the developer, so that like it also makes assets inside of like third-party crates much more approachable, because for a while there it was very much like you just had to hope that they didn't do anything wrong and that it was your own that was causing a problem, whereas now it's possible that one of these 4 different things is like, hey, this is an error with our crate, not you, so file a bug report. App exit errors. When running an app, there might be many reasons to trigger an exit. Maybe the user has pressed the quit button, or the render thread has encountered an error and died. You may want to distinguish between these 2 situations and return an appropriate error code. Okay, so now I guess the apps can exit with error codes now. App exit success. Yeah, so you can error code 0, exit code 42. That's nice. So basically, you can now give the app an exit code so that you can have different fail conditions have different error codes, which means that like in a release build, you don't have to necessarily have like a console log out a bunch of stuff. You can just be like, yes, you hit this error or that error. Make dynamic linking and no-op on WASM targets. Okay, WASM does not support dynamic linking. That's pretty straightforward. Deprecate dynamic plugins. Bevy dynamic plugins was a tool added in Bevy's original 0.1. Fuck, I thought dynamic plugins gave it like 0.6. Anyway, it's intended to serve as a tool for dynamically loading and linking Rust code for use with things like modding. Unfortunately, this feature didn't see much community uptake, and as a result has vanishing small number of contributions to refine and document over the years. Combined with the challenging potentially unsafe API that was producing worrying failures for users, we decided to deprecate the plugin, and we're removing it completely in 15. If you were a happy user of this, simply copy the rather small crate into your own project and proceed as before. That's neat, because so basically they said nobody's using it, there's not much done to it, so if you are using it, maintain it yourself, which and it was like it's just too unsafe to leave, I guess. So it's like we still think both modding and hot relink code for fast development times are use cases that Bevy should help support one day. Our hope is that by removing this as a first-party crate, we can spur a third-party Okay. Yes, they literally are just saying like, hey, nobody seems to be using this. If you want to improve it and make it better, do so. But we aren't going to support it anymore. And that's yeah, good way of doing it, I guess. Oh god, there's so much, still so much to go, but there's probably like lots of. Oh yeah, so we're at the what's next. Okay, I was going like we're only 2/3 of the way there. Bevy working group. Bevy has tons of incredibly talented contributors, so we keep track of what's going on and making informed decisions. It can be real challenging. We're experimenting with working groups, ad hoc groups, tackling harder issues by creating a design document, getting sign off from the experts, and then implementing it. If you'd like to help make complex high impact changes to Bevy, join or form a working group. Okay, what's next? Better scenes. Okay, scenes is one of Bevy's core building blocks, designed to be a powerful tool for authoring levels. Okay. So what are we looking at? So better scenes. ECS relations. Relations, a first-class feature for linking entities together, is widely desired by, but remarkably complex, driving features and refactors to our ECS internals. The working group has been plenty layout. What do we need to do and why in this RC? Okay. They didn't really explain what ECS relations is. Is that like hierarchy but not hierarchical? I don't fucking know. Better audio. That's gonna be cool. Contributing book. Our documentation on how to contribute is scattered in 4 corners of our repositories. By gathering this together, the contributors book working group hopes to make it easier to discover and maintain. Curve attribution, better text, a unified view. On DevTools in 0.14, we added a stub, Bevy Dev Tools, create a place for tools and overlays that speed up game development, such as performance monitoring, flying camera. Ooh, yay! Flycam will be part of Bevy, like actually maintained by the developers. I'm so sick of having to try and having to implement a Flycam in every single game that I make because the official one doesn't get updated anymore. Or like not the official one, like the crate Bevy Flycam doesn't get updates quickly at least. Or in-game comments to spawn game objects. We're working on adding more tools and creating a dev tool. This will give us a unified way to enable and disable, customize, and group these grab bag of tools into toolboxes to create something like Quake console, VS Code command panel with tools. That's nice. So it seems like the dev tools is going to be like sort of like just all the little bits and pieces of tools, maybe from the community and whatnot, that they put in place as like the Bevy editor and stuff like that. Maybe not that one, because I think they're going to add their own custom editor, but like, you know, the Quake console and the VS Code VS Code command and stuff like that, like they're crates that I've used. So, you know, it'd be nice to have them like as part of Bevy instead of having to be like not, well, because it's more like it'd be nice to have them all in one place so that you know they exist more than anything, because I usually stumble across them when I'm looking on the Bevy assets or doing something else where it's like, oh, this exists. So okay, Bevy remote protocol communication with actually running Bevy games is incredibly powerful tool for building editors, debugging, or other tools. We're developing a reflection-powered protocol to create a solution that's ready to go for a whole ecosystem. Okay. A modular, maintainable render graph. Okay. And then, yeah, so this is the rest of it. Just apparently, there's just so much went into this that it's just like a third of the page is just stuff. Okay. Oh my god. Thank you to anyone that watched that whole video. That that was a really long update. And double thanks to anyone who watched the live stream. I am going to probably not edit this today, and will instead like upload it later. I don't know. Maybe I'll edit it after I go for a nap. But this live stream's like 2 hours long, and God, I hope it fucking recorded the audio, because if you guys have been sitting in a silent fucking stream, and that's why I've only had like a concurrent of 2 viewers at a time, I'm gonna be so pissed because I'd have to record the whole goddamn thing again. It doesn't sound like I was muted the whole time, so that's good. I can hear it on my phone. Anyway, I hope you all enjoyed the stream, and I was planning on doing like another thing of updating my Minecraft clone to the latest version, but I'm so knackered. I am going to go have a nap and probably edit this video later. That's good. I was like, because every time I check my app, like it's like literally like one person was watching, which isn't always accurate for some reason. The YouTube fucking stream just sometimes just says one person's there, even though like, and half the time it's me that it says is there. But I was going like, oh god, I hope it's not that I've just been like a silent thing so people kept coming in and leaving. It's probably more just that I couldn't update the thumbnail because I had to do it from my phone, and the issue with the phone doing it from your phone is YouTube then says it's a phone stream, so I had to do it from my phone, but in a web browser on my phone, because if I do it from the YouTube Studio app, it'll treat it as a phone live stream, and it can't then be streamed from a computer, which is just insane. But yeah, hope you all enjoyed, and I should hopefully be doing more videos soon. Like my plan now that 14 is out, and well, 14 actually like literally hit the nail on the head. It changed a whole bunch of things. I was going, man, I want to redo my Bevy Basics series. Maybe split it up a little bit more, so it's Bevy Basics, which is like you have to watch all these videos. So that'll be like entity systems, resources, events, queries, things that like in other videos I will talk about with assuming that you know what these are, and then I'll do one like how to get user input, how to do this, how to like, and then it'll be like called like Bevy Essentials or something, and it's going to be like the actual code, whereas Bevy Basics will move away from like talking about how to do it in Bevy and instead be like, hey, an entity is this, and then in a different video it's like, hey, like this is how you make a player move, and so that'll be 2 series sort of thing. And I want to like go through it as like a redo all my stuff. Originally I was planning to do it animated and have it ready to go like when 14 came out, but I've learned I can't edit. If I can edit shit, like I can't animate for the life of me. So instead it'll probably do the slideshowy thing, but I do like now have the capability to do some animation, so there'll be like hopefully more like dynamic stuff in them. And I hope everyone's looking forward to that, and I'm going to see if I can work out how to close this stream now without like doxing myself. So we're gonna stop recording. We're gonna